Greetings, ladies and gentlemen. This is Luandile here, the leader and the instructor of Manikwe School. And if you don't even know what is Manikwe School is actually a school that is dedicated to teaching programming by means of going through a certain book and simply go through each and every exercise on the textbook. Not only we going through each and every exercise, but we also go through those exercises in 3 different ways, basically in at least 2 ways. Of course, there are gonna be exceptions because some of the problems are pretty straightforward. And on such problems, there will be no need for one to put too much effort trying to repeat one and the same thing. Okay, with that out of the way, I hope you guys can see I've created a project I've created a project and I've called it exercise 2.9, and the class inside that project called exercise 2.9a, and then underneath the class name there's this link. I will try to scroll slowly. I hope everyone can see. This is actually a link to this textbook we're actually working on. This is a Java textbook I decided to give solution for. And just so you know, it's not like I'm taking my solution anywhere. I just go through them on my own, and I bet there's no way you can find my solutions maybe equivalent to any solutions you've ever faced. Of course, the algorithm might be the same, but I just want you to know these are my solutions. It's not like someone else wrote them down for me. Okay, with that out of the way, again, if you're curious, why did I pick an edition which is actually not the latest one? The reason is straightforward. I don't want you guys to copy and paste my solutions, but rather I want you to gain more than I anticipated out of this channel. Okay, right now we're gonna be jumping onto the programming itself. Okay, so what question we're actually doing? We're actually working on question 2.9, the one at the top. So let's read it through. Okay, it's physics. It's an acceleration problem. So average acceleration is defined as the change of velocity divided by the time taken to make the change, as shown in the following formula. Okay, as you can see, you guys, A is equal to Vf minus final velocity minus the initial velocity all over change in time. Okay, so we gotta write a program that prompts the user to enter the starting velocity Vo in meters per second and the ending velocity V1 in meters per second. Okay, the time spent T in seconds and displays the average acceleration. So here is the sample run. As you all can see, this is a pretty straightforward solution, you guys. So there isn't much we can play around with. So scanner input equals to new scanner. We all know why do we need a scanner, so there's nothing much you can say, or rather I can say about that. Again, this is what I said in the last tutorial. If you go input.close, you won't need to concern yourself about importing the class. Okay, so here's what we're gonna have. We're gonna have an init velocity. It's actually an initial velocity. Let's put VE. Final VE L, and then time spent. Okay, for the velocity, the final velocity, and the time spent. So system.out.print This is what we have when I have enter v0, v0, v1 and t. Once we do that, we simply go init val equals to input dot next double. Likewise for final val input dot next, and finally one and the same thing will. So time span will be no exception. Okay, so time span, how do I do that? Okay, no, next double. Okay, now that we've got our variables, we will simply go, we will declare another variable, call it average acceleration. Simply gonna go final val minus init val all over time span. That's pretty much it. We'll then simply system.out.print the average acceleration is AVGACC. Let's take this as an input. This is what we have. Oh, let me see. I forgot this file over here. I mean, I didn't copy the 5. Okay, let's start over now. Let's rerun our program. Copy and paste. Press that. Why do I get that? Oh, it's actually a correct answer. It's just that student A happens to be stupid enough in a way that he did not even round off his answer. So we're gonna take care of that on our next episode. Cheers, you guys. I'm gone.